All right, so what we're gonna do is we're gonna show you the other side.
I bet Tyson won. To be That's my last page.
I saw this happen in the
I don't think.
That's why I don't think everybody should invest on an iPad and Apple Pencil. Then you can keep all the notes here.
I'll tell my parents that.
Or you can use a laptop like this.
It's so much easier. You just carry your iPad. You can go anywhere.
Something about writing it out.
As soon as I get money, sure.
It's something about like writing everything out.
Yeah, but you can write it here too, and you're not gonna lose your notebook. You're not gonna lose your iPad.
I don't lose my notebook.
And you can color code. You don't have to bring different color pencils.
You can like make it go away like with the button.
Yeah.
You write it and then like.
Yeah, no, it's actually, I think now, like, if I were reinvent education, I'll give everybody iPad. Huh? Yeah, I don't think computer is that effective, though. I can turn an assignment into an iPad. I can write it out and enter it.
What app is that?
There's a Notability. You can download a PDF, like your teacher give you a PDF file, right? You can download it and you can upload it into Notability, and you can write it out and you can send it back again. I don't think like the other high school does that. What's the First Academy? That they do that. They just give everybody an iPad.
Yeah, because they're.
I thought that was like a private school.
Exactly.
Yeah, they're a private school.
Okay, that explains a lot.
That's pretty good.
Some people physically have.
Is there like a redo button?
Huh?
Have you ever pressed undo? Or, like, is there a redo button?
Yeah, there's an undo button.
No, is there a redo? Well, like you accidentally pressed undo and you undid like most of your notes. Yes.
Write it again.
That's true. They don't have the undo button.
Yeah.
That's true. They should have invented that. Control C, Control Z. All right. So, again, I'm gonna tell you there is average rate of change. So the reason why I work this out is I don't want people to get confused, which is average rate of change is f of b minus f of a over b minus a. Okay, so this is average rate of change. Now there was an instantaneous rate of change.
That's mean value.
If they equal each other, it'll be it'll be equal to each other. So f of c is equal to something, right? So that's equal to f of c. Now if they equal to each other, then it's gonna make mean value theorem.
What's the title of these notes?
I will tell you in a second. So this one is the mean value theorem. So you can actually memorize a lot of things. Now, today what we're gonna learn something is called average value. So the one on the left, we already learned it. Now the reason why I repeat again, because a lot of people can confuse between average value and average rate of change. Now, average value is going to be integration of f of x dx between a to b, and that's going to be 1 over b minus a. Now, I'm going to write in different color. 1 over b minus a. Now, what's interesting about this is I'm going to talk about a 4th grade thing, or 3rd grade. If you're doing division as 2nd grade or 3rd grade, I forgot. Division, right? 2nd grade?
Third.
I think it's my
It's one of them.
2nd, right? So, do you guys understand what is the division sign mean? So for example, I have 13 divided by 3, right? But what is this notation really represent? That notation of the 90-degree thing? Well, yeah, it's division. It's a division, you're right, but
it's a lesser square root.
What is that symbolic of? Not symbolic. What is that representing? Why do they draw a right angle? Why don't they just do like a triangle like this? Or why don't they just, I don't know.
That make it look nice.
Why don't they do like
Because
a
they don't
angle
want it to
12
look
like
too much
this?
like a square root, right?
Because it looks good to second grade.
It looks good on second grade. Okay, good.
Yeah, it's also easy to draw
It's also easy to draw, but draw what?
a right angle as opposed to like a that.
Almost. So it turns out, I'm going to show you a little bit different. So I'm going to draw that line all the way to here as it represents 3. Hopefully that help you a little bit. So that is a rectangle, right? Area of 12. And if you have a side is 3, the other side is must be 4.
Oh my gosh, that's crazy.
That like blow your mind like completely.
What if it's different numbers? You make a bigger thing?
Well, yeah. But the idea is if it's an area, so the idea is if you got area of a rectangle is 12 and the one side is 3, that means 12 divided by 3, you're gonna get the other side. That is a fundamental understanding of division, because that's what division come in play, is the area relationship width and length, which is good. You guys actually realize that. Now, what we're gonna introduce you is this. This thing here is actually interesting. Is if I have some type of functions, right? If I have some type of weird functions, and I'm gonna go with sine function because I kind of like sine function. I'm gonna connect all those points, and with a sine wave. Okay, and I'm gonna draw a line here for the boundaries. Okay, so now this is the f of x. Now if I have integrate of f of x dx between a to b, so that's gonna be a to b, right? So that becomes this area, right? Now, what if I have 1 over b minus a? Well, this 1 over b minus a is basically take this graph and divide it by the width. Of course, you're going to get the height of a rectangle. Does that make sense? So you're going to get this height of rectangle around roughly right here.
That's like a big point.
Well, in this case, I just draw midpoints for you easier to see, but it don't have to be in middle. They can be somewhere else. You can have more than one point intersecting. But in this case, it's a wave function. So the area of the red, right under the curve, is equal to the average value, which is the height of a rectangle. The height of the rectangle times by b minus a, right? So times the b minus a, which is divided by that. If you divide it by area of red, divide by the width, is okay. Let's do this. Divided by the width, right? Which is b minus a, right? So it's equal to average height of the rectangle represents same exact area as the other side. Does that make sense? So visually, it basically takes this part and just fit it right here, it becomes a rectangle. Yeah, just slide it, and it's just going to be a rectangle. So that rectangle had the same area as the area of the graph. Okay, so this is called the average height of that rectangle. That rectangle represents the same area as that weird line under the curve. Now this is a nice little niche thing, which is called average value. Now it turns out in calculus, there is something called mean value theorem for integral. So there is a mean value theorem for integral. Now, why is mean value theorem for integral? It's basically the same. F of c b minus a equal to integration of f of x dx. A and b. Remember, this f of c is the height, right? And this is the width, right? It's equal to that rectangle. Does that equal to that area under the curve? Because if you divide by both sides by b minus a, what you get? Average value? So height times width. Now, what's cool thing is mean value theorem in integral says there is a value of c here. At that particular c, I can find the height. It can be more than one value though. Can you think of a situation can have more than one value to get the same height? Well, if I shrink the compression of the wave, make sure that wave go complete twice, I'm gonna have 2 points have that exact same height. So just like mean value theorem for derivative, they are sloped exactly the same way. And here there's this 2 type of value. It's gonna give you c, that give you a height of that situation. This is a fundamental understanding of calculus, is to see those things visually and see it happens. I don't know, did I confuse you or not?
It makes sense. I just kind of like put it together, put everything together. You know what I'm saying?
Okay, so let me repeat this again. This represents the area. Now, if you divide it by the blue line, which is this one, the blue, then I'm gonna get this rectangle. This rectangle has a height, which is this called the average value. Does that make sense? So this is this part here is a average value. Okay?
Why is it average value? Why isn't it just?
I don't know why. I didn't name math. I don't, you know.
I don't see it.
Well, then it'd be like yang or something.
Now, what's nice thing about this is just a different format of average value if you pay attention. If I times both sides by b minus a, I'm going to get f of c. Now, this one just going to be the height times the width of a rectangle is equal to area of that. That makes a lot more sense. You can think of that way too. But sometimes you want to find the value of c. So sometimes you want to find the c value. C value at 5. At 5, you're going to get the height. It's going to represent the average height of everybody. Now, it could be more than one height because I can have a graph like this, right? So at this place here, this and this and this, all the height that you will get. It's going to represent exactly same graph as before. So that's a fundamental understanding. If you don't understand it, it's not a big deal. They don't test mean value theorem for integral that much. They do sometimes, but you know, it is what it is. So you have to, you know, it's one of the things is a minor topic, and that's okay. Now we're gonna talk about last 10 minutes, the major topic.
Really last one?
The major topic. So this one is just very easy to calculate. Anybody can calculate this. And you know, we don't have to give you too much work. I can give you x squared. You can do 1 over b minus a. So the calculation is not a problem. The understanding is a problem. Now the next thing is called fundamental theorem of calculus. Yep, it's on your notes. Calculus. Did I spell calculus wrong? Okay, calculus.
LUS at the end.
Okay, so it's also FTC part 1. FTC part 1 says integration of f of x dx between a and b is equal to f of b minus f of a. That's that. We already know this. When we're doing definite integral, when we integrate of a non-capital F, it's gonna give you a notation of capital F of x minus f of a. F of b minus f of a. This is something we already learned before because this is definite integral. Now I'm gonna talk about FTC part 2. Now this is really hard to understand, so you gotta open up your mind. Zach, wake up. So integration between a and this is the only time is x. I'm gonna write in red. X. It's a variable, not a constant anymore. The first time you see a boundary is a variable. And with I'm gonna take a derivative after that, after you take an integral. And I'm gonna have a f of x dx. Now, at first, the black part is the part that we already understand. We can take an integral of this, is eventually it's gonna give me this. So eventually it's gonna give me a f of x. And you're gonna be like, Mr. Yeah, do we really have to do this? This is redundant because if you integrate something and you take a derivative afterward, that's just gonna get back the same thing. It's technically true, but here's the truth, also true, is if you take a hammer and nail, okay? If you nail the nail the hammer in the wall. No, hammer the nail into the wall. Damn, I can't speak English today. So hammer the nail into the wall, but you know the other side of the hammer, you can take the nails out, right? So when you hammer in, it's the action of integrate something or antiderivative of something. When you take it out, it's a derivative of something. So when you take it out perfectly, if you are a perfect handyman, that you can take out a nail completely out. Now, if you're a snowflake like me, then when you hammer in, when you take it out, the nail is going to be crooked. Does that make sense? So I'm going to show you what happened. We're going to talk about a perfect situation. So a perfect situation is the nail goes in and come back out. It's exactly the same. So I'm going to d to the dx here of integration of a of f of x dx. I'm going to show you what happened. If I take a derivative of integration of this, it's going to be big f of x minus big f of a. Is anybody confusing so far? If I integrate of non-capital F becomes capital F. Now I'm going to take a derivative. If I take a derivative, it's going to require chain rule. And that's going to be matter later. So if I take a derivative of big F, that's going to give me a small f of x, right? Times the chain rule. This is the part as a chain rule. And usually people forget. And I'm going to go back to black of f of a times derivative of a is what? What's derivative of a? It's just 0, right? It's a constant. So can it go away? So that's equal to f of x. So you say, Mister, you don't need to teach me that. I already know how to do this. I know you know how to do this. But the problem is I still had to show you this chain rule involved. Because the next situation is non-perfect situation. If I say, hey, can you take a derivative of this function? A, instead of x, I'm going to change to x squared. And I'm going to use a function that you never seen before, and you're going to be scared the crap out of you. So ln of t dt. We got this function. We don't know how to take integration. Matter of fact, until end of this year, you still don't know how to take integration of this one. Because this one's in Calc 2. So you will learn it next year for some of you guys. Derek's like, see ya. Okay, so now here's the issue. The issue is, do you know how to integrate natural log of t? No, we don't know. And you know what? I don't really care how to take an integration of natural log of t. I'm going to show you why. I'm going to show you a powerful idea. Assume, not ask. Assume of f of t is equal to natural log of t. Now, if you assuming this, this is something very interesting. D to the dx of a to the x squared of ft dt. Does that make sense? If I just change natural log of t to f of t, it's some type of function anyway. Now, remember, it's not, assume part is very important, okay? So now, if I integrate this, what will happen? If I integrate this, it's going to be big F of x squared, right? Minus big F of a, right? If we integrate small f to become big F. I didn't know how to integrate that. I don't know how to integrate that. I'm just going to say that's went from small f to big F. That's it. I don't care about natural log of t. I'm going to take a derivative of this. Now remember the chain rule is equal to f of x squared times 2x. So chain rule and the minus f of a times derivative of a, which is chain rule. And then that's equal to f of x squared times 2x. Now the best part is, it already says f of t is equal to natural log of t. What happened with f of x squared? Natural log of x squared. This nail is completely bent. And I didn't know how to take integration of natural log. I totally avoided it. I didn't care about how to take an integral of that.
So it's like substitution.
It's substitution. And you just rephrase it and package it something else, and then to change it, and then you take it back, it becomes the same. But the problem with chain rule kind of affects this nail. It's no longer natural log of x. It's actually natural log of x squared times 2x. Understand?
Wait, rather than natural log of t, or rather than natural log of x squared?
Because you plug in x squared into f of t. So f of t, that means you plug in t into the function, right? If I plug in t in the function, I get natural log of t. If I assume that, then that means f of x squared, that's equal to natural log of x squared. So this, I didn't know how to take integration. I totally avoid it because you take integration and derivative. So I just totally ignore the integration part and the derivative part. I only need to know how to take a derivative of x squared, which is that's something we know how to do, which is 2x. So that's a fundamental theorem of calculus, part 2. Now this one's a little bit more difficult than part 1. So today I'm just going to give you 1 or 2 questions. It's not going to be a lot. Most of your questions is going to be on use substitution review, and your trapezoid and the midpoint rule. I'm going to give you a test question and make sure you guys like it. So the first question is going to be, I'm going to write your homework right now. You don't have time left, right? So the first question is going to be interesting. F of x equal to 4 to the x. Ooh.
But what's the question?
Between 0 to 2,
Thanks for another great Titan day.
4 sub
You are now dismissed.
interval. 4 sub intervals.
We can use a graph calculator for this stuff.
No, this one's no calculator.
Oh, that's why it's interesting.
I get to plug in numbers again.
Yeah. No calculators.
Wait, 4 sub intervals from 0 to 2?
0 to 2, yes.
So,
Like to include
yeah,
that though.
0.5.
I don't know how to do 1. I don't know how to do 0.5.
By?
0.5. Oh wait, it's fractions.
Unfortunately.
So this one, I'm going to ask you to use
You won't see me tomorrow.
right.
No, after. Mr. Yeah, I won't be here tomorrow.
Why?
I have to drive to St. Pete.
Oh, okay.
Yeah. No. He wouldn't do that to us.
Wait, I just realized that
What is that?
Cat fungus.
Oh, that. It's pretty cute.
Okay.
That runs. Yeah. Thank you, Michelle. Bye. Bye, everyone.
So this is a 4 subintervals. Daniela, remember, ask questions in class, not my lunch. I'd rather answer your question because if I answer your question at lunch, I only reply to one person. If I answer in class, I answer to a whole bunch of students. So you ask, don't feel stupid. You are the most important person in this classroom. That's it. Don't give a shit about other people.